Hi, Math 7 students. So this week we'll be doing kind of a crash course in statistics. So really we'll kind of be covering just the first part of topic 6, not the supplemental part. So we'll be looking at kind of 6.1 and maybe a little bit of 6.2. And then just to kind of cover some of the major parts of topic 6, I might give a little mean, median, mode stuff to kind of recap and maybe tack on a little bit from what you knew from Math 6. But for the most part, I'm going to pick out the real important part of topic 6, which is sampling and statistics. So basic goals of this week is we're going to try to understand what a sample and a population are. And then we're going to try to figure out when a sample accurately represents a population. Again, we'll define those terms real soon, but just to kind of plant what we want to get to. And then finally, we're going to try to understand why a random sample is important. So our big jumping off problem is going to be this solve and discuss it problem that I posted on Friday. So just to make sure that you guys kind of have something already in your brain to connect to, if you haven't done this problem yet, go ahead and pause the video and do that. But let's go ahead and jump in for those who have. So to start, we essentially have, and first actually let's glance upon how insanely terrible this veggie burger is, just throwing raw vegetables into two buns. That would be the worst. But we've got a cafeteria manager and they're looking at the lunch orders for, looks like one day of the week at a middle school cafeteria. And so we've got one day to look at. And essentially, you've got how many have sold of each. So they offered 4 different items, like your turkey sandwich, your hot dog, your veggie burger, which looks absolutely disgusting, even though I like veggie burgers usually, but this one, not so much, and our fish tacos. So we've got the numbers for one day, and let's just say this is maybe Tuesday's orders just to make this problem a little bit more real. So we've got the orders for one day, and we want to figure out what this cafeteria manager should order for next week. And so some things might run through your minds, like what if we had more data? But we've only got one day's worth of data. So a lot of you might come through and say, well, there are 43 turkey sandwiches per one day. And you could just make kind of an equivalent ratio and say like, well, if it were one day, well, we could figure out what we'd have in 5 days pretty easily, like a school week. And you could just multiply the number of turkey sandwiches on one day by 5, and you would get kind of that missing number. You could go through with hot dogs, do the same thing, and you could extrapolate it out to 5 days. But the big question on that, and we'll just do one of them, just to kind of say, hey, let's put like a pin in this. You could say, well, hey, tell them to order 255 hot dogs because that's what we're estimating we'd use in 5 days. But we're making some assumptions here. We've got a snapshot. We've only got one day, not 5. And we're assuming that this snapshot is a good sort of typical day at the middle school, or kind of like a good representation of what it would be for the week. But we don't know that. We could have, let's say it could have been National Fish Taco Day, and usually no one ever gets fish tacos because they're really bad at this middle school cafeteria. But today, people bought 27 instead of 0 of them. Or I'm going to use stick figures a lot for this lesson, so here's like your sneak preview. Let's say Timmy took up the hot dog challenge. Here's Timmy. And normally no one buys hot dogs, and just today only on this regular old Tuesday, Timmy decided to eat 48 hot dogs. And so it skewed these numbers real up. So we're making some assumptions here when we do this math that this is a typical day. And so just to kind of tack on what you did here is I like to kind of relate this to something you know. I'm sure you guys have all been to like a Costco or some place that does free sample. So we got this lady giving a free sample, and we could even just write sample. So we could say the sample is this little tiny hot dog that she's offering you. And from that, if you taste it, you get a good idea of what the actual whole thing is. And when we talk about this in statistics, we call this the population. So you can think of sample, small thing you're studying, and let's draw a little package of hot dogs. Bloom, bloom, bloom. It gives you an idea of the population, the whole thing. So these get kind of tricky though. There's a lot of weird things in this. So sampling and statistics could tell you a lot about the world, but if you don't understand them, they can get really bogged down, and people can also use those kind of like misunderstandings about sampling and populations to purposely do things that will kind of manipulate you. So you want to kind of inoculate yourself from that. So let's look at that now. So I'm going to use the question of, let's say you were trying to investigate who Seattle's favorite sports team is. So I know there's going to be like some Yankees and like some Patriots and like some fans from people that aren't teams from Seattle, but we're going to take kind of the big four Seattle sports teams just to make it so I don't have to draw like 25 different stick figures to keep it a little bit more bite size. So I made a key here, and let's just say I'll represent any like person who is like a #1 Seahawks fans. I like the Seahawks the best. They'll be in blue. Storm fans in yellow if Storm is their #1 team. We'll do kind of like this dark green, like an evergreen or forest green, and we'll do the rave green for the Sounders. So on that, we've got a couple options if we wanted to figure out Seattle's favorite sports team. So Seattle's going to be our population that we're studying. We could ask a ton of different questions about this population, but I'm just going to narrow it down to this one. So we got a couple options here. So option one, there are 744,955 residents in Seattle. Last time I checked, we could track down each and every one of these people and ask them individually. I don't think either of us want to do that, but we got a second option, just using some statistical properties that makes this problem quite a bit easier to investigate. So I could take a sample, so like a small subsection or like assortment of people, and if it represents the Seattle's population as a whole, I could just say this is a good snapshot of what Seattle thinks their favorite sports franchise is. So we're going to kind of look into this. But the thing is, though, you probably don't want to ask like one or two people. You want to ask like a fair amount. You don't have to ask all the people, but we'll talk about a little bit more why a larger sample is better. But we want to ask a fair amount of people. So here's the scenario I'm going to give you. I'm going to say, I want to find a lot of people. Where are a lot of people in Seattle? So I'm going to stand outside T-Mobile Park. I know we don't have baseball games this year because of the shutdown, but let's pretend it's 2019, or if it's 2021 and we're kind of resuming sports again. And I'm going to wait outside T-Mobile Park after a Mariners game, and I'm just going to ask some people, what is your favorite sports team? And I've kind of represented them here. Let's get this guy off of these stands here. That's dangerous. Let's bring him down. So I've kind of put here kind of what I think a typical crowd leaving T-Mobile Park would be. And I'm just going to ask them. And this is going to be my sample to figure out what the population of Seattle's favorite sports team is. So a lot of you can already see it. But what's the flaw in my plan? And you can even kind of see it illustrated with this smattering of people. We got a sample of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, which is a pretty small sample, but more than one or two. You could probably get something from this. But you can see that most of these people are Mariners fans. And so the key here, when I take this sample of people and I try to use that to make like a conclusion about a population, you can see that really this portion of the population was much more likely to be selected. So this is a biased sample. You've got a ton of Mariners fans here, and they're there for a reason. They're probably there because they like the Mariners the best. Where you would probably find a similar scenario if you waited outside a Seahawks game or a Storm game or a Sounders game. You're of course going to get some people that wander in that just like baseball as well, but most of the people are there for a reason. So this is a very exaggerated example on a biased sample, However, you got to be really careful with this. Even if I were to say, like, let's go to some place that everyone goes, and I say, I'm going to wait outside a supermarket at like 9 a.m. in the morning and ask people as they go in, you're going to get a certain kind of people that go to the supermarket at 9 a.m., and that will actually bias your sample as well. So the question becomes, what do you do? And so our key here is we want to get something that's representative of Seattle as a whole. We want every one of these people to have an equal chance of getting selected. So no one of them is overrepresented in our sample. So the key here is we're going to try to make sure that everyone in our population has an equal chance of getting selected. And so one of the key things in here is we want to make sure it's random. And let's fix it. Not random, random. So let's say this is like a population of people. I'm not going to put 750,000 stick figures down here, but you can kind of get the picture. This is a big smattering of people. I've kind of interspersed them on purpose so they're all kind of spread out. And if I take any, and let's actually just kind of label this. Let's say this whole thing is my population that I study. I want to make sure that when I take an intersection of this, that it's just completely random. The people that get selected for my sample have an equal chance of getting selected. So we're gonna kind of do like a little like pop quiz on this. So when I flash these three kind of scenarios, we're gonna kind of quiz ourselves. So I've written three scenarios here that I've made up, and on each of these, I want you to find the sample, find the population, and tell me if the sample represents the population. So I'd recommend kind of like pausing this video, like read through question 1, see if you can find the sample population, tell me if it's representative, and then like play the video, see if you got it right. So again, we want to make sure no part of the population is overrepresented and that everyone in the population has an equal chance of getting selected in the sample. So we're going to start with question 1. Again, kind of pause and resume at your leisure. But first, we're going to try to figure out the favorite TV show at JAMS, so Jane Addams Middle School, by polling 20 random students in your math class. And I make sure random. So let's identify our sample. 20 random students in math class. And our population that we're trying to study by this is JAMS. So key thing here is random, which makes it more representative. Everyone in our math class is being represented, but if you're in my math class, you're very, very likely in 6th grade. And you can see that if your population of JAMS has 6th graders, they have 7th graders, and you have 8th graders. And if you sample your math class, at least if you sample mine, you're really going to over-bias this population. So you've overrepresented 6th graders. You haven't really pulled any 7th graders or 8th graders. So here, is it representative? No. I have oversampled 6th graders from my population, and I haven't really asked the 6th and 7th graders. So if I'm trying to figure out JAMS as a whole, I've got a bad sample. So now we'll go ahead and look at number 2, and again, pause if you feel like you want to kind of test yourself on this. So we're going to look at trying to figure out which video game people like more at JAMS by picking random people out of a yearbook and asking them. So we got our population of JAMS again, and our sample random people from yearbook. And so here we're kind of saying, does this sample represent the population? If I were to take this sample, could I make a good valid inference or a good sort of guess at what the population of JAMS thought? So here, the answer is yes, because if you look at the yearbook, it includes the entire population of JAMS, and I'm picking people out at random from it. So yes, it is a representative sample because each and every person has an equal chance of being selected. So you want to be careful because even if you have a random sample and everyone has a equal chance of getting selected, you want to make it fairly big. The smaller you get, the more likely that just random variation happens and that you accidentally pick out too many of one certain type of people and you don't get like an even view of things. So let's look at number 3 now. So this one's a little exaggerated, so hopefully we're on the ball now, but trying to figure out which political position people support, and I'm just going to be very vague in this. Well, if you, in your head, you can choose any political position you want, but trying to figure out which political position people support in the United States by pulling people at random out of a phone book in Florida. So pulling people random out of a phone book in Florida, that's a pretty good strategy, but let's get our sample and population really hone in on that. So sample, we'll just say phone book in Florida, and our population, the entire United States. So, pulling people out of pulling people out at random out of a phone book, great strategy. Everyone has a equal chance of being selected. However, I only selected people from Florida, and as you can probably imagine, here in Washington, there's probably a definitely different climate in terms of what people think than people in Florida. So here, even though this was random, this here was biased. And so here, is it representative? No. So hopefully this is helpful. We'll do kind of a sampling work for the beginning of the week and just to kind of like make sure you guys get the meat of sampling and statistics. We might do like a little bit of review on mean, median, mode later in the week, like stuff you learned in Math 6, because it'll be important going forward. But on that, I hope to see you guys all for our office hours on Wednesday, and I hope you have an excellent, excellent, excellent week. Take care.